All right, I'm Lauren Spencer with Reagan High School. Today we're going to learn how to CUSS and BS about quantitative data. Obviously, CUSS is a acronym, and we'll go over that in just a moment. But please note that we can only display and describe data that is quantitative in nature by this method. It's qualitative, order and things like that do not apply. So we do not CUSS and BS qualitative data or categorical. We only do that for quantitative data. This is going to be a longer set of notes. It's page 48 through page 50 of your note spiral. All right, so looking at your note spiral, page 48, we see that CUSS is the acronym Center, Unusual, Shape, and Spread. So anytime we're talking about data, we need to talk about, or describing data, we need to talk about those things. Not necessarily in that order, but those are the things we need to talk about. BS means be specific, give actual values, make comparisons. So C is for center, and that's the measures of the middle. And normally we use the mean and the median as our measures of the middle. And we learned how to calculate that just on the last video. Unusual features are gaps, clusters, and outliers. An outlier is a value that's way too far away. A cluster is a group of data. A gap is just having missing some data at a single point. Shape, we have different types of shapes: skewed left, skewed right, mound, uniform, bimodal, and multimodal. I'll show you pictures of those in a moment. And when we talk about spread, we typically talk about variation, range, interquartile range, and standard deviation. And that's just how spread out the data is. Is it close together and really narrow, or is it really wide and spread out? Okay, so make sure that you always talk about these. And most importantly, center and spread. And by the way, once again, I'm not going to read everything on the page. You need to do that. It'll expedite the videos and it'll help you with your learning. I just kind of give an overview so that you have an opportunity to understand what's going on. All right, moving up. So measures in the middle, the mean. It's just the average of all values. We added up and divided them by the number of values. The mean is impacted by outliers and non-symmetric distributions. So at this point, we would say the mean is not as useful if we don't have a symmetric distribution. If the distribution is symmetric, the mean is pretty good. If we have outliers, the mean isn't so great. The median, on the other hand, is the middlemost value. It's not impacted by outliers, and it's not impacted by shape. So if you have some weird shape data, the median is pretty useful. And 50% of the values are greater than the median, and 50% of the values are less than the median. If the data is symmetric, write this down, if the data is symmetric, the mean and the median will be equal. If the data is symmetric, the mean and the median will be equal. Unusual features, a gap is a section without a data point, usually a single section, maybe two. Clusters are two distinct groups. Instead of having a big mound of data, we have two distinct groups of data. And if a cluster exists, we should describe shape and spread of both clusters. That's a requirement. An outlier is a data that's either too small or too large. And we, in this course, identify them in two different methods. And we'll go over that later. But once again, I just want you to understand that 2 to 3 standard deviations above or below the mean is considered an outlier, or 2 to 3 standard deviations above or below the average, or more than 1.5 interquartile ranges. And you're like, I don't know what an interquartile range is. Don't worry about it. You're going to learn about it in fairly shortly, not in the next video, but maybe 2 videos from there. All right. So unusual features, make sure you list those. The next S is for shape. All right. And the first type of shape that we have is symmetric. In other words, if I cut it in half, if I drew a line and cut it in half, I could fold it and it'd be symmetric. And all of these represent some sort of symmetric data. Pen's inking out, but we'll survive. A graph that is uniform is approximately the same height. This is the same height. but it doesn't have to be exactly the same. It says approximately, and we like that word because data isn't perfect. And if you think about it, if I was rolling a dice, I can get a 1, 2, 3, 4, or 5, or 6, and all the probabilities would be 1, 6. So the dice would have a uniform distribution as far as probability. When we see something like this, all my students want to say, it's normal, and the answer is we don't know that. So we like to say it's mound shape or bell shape. I like using the word mound shape because that's what AP likes. Personally, I like bell, but AP likes mound. So we're going to use the word mound shape. Don't call it normal until we prove that. If you noticed, it has a lot of data in the center, or close to the middle, and very little data out at the ends. It gets really skinny out there. Okay. Skewed left. The data is to the left and the mean is less than the median. All right, and what that means, what that says is if this is where my median is, if 50% of the data is larger and 50% is smaller, my average, this would be my median, my average, and I'm going to pause this for just a moment. You have to excuse me, I'm going to try to get a pen that actually works. Oops, that didn't work. All right, resuming recording, hopefully that works. So if this is where the median is, I know the mean is to the left because it's skewed left. How do you tell if it's skewed? Think of a piece of bubble gum. It's been stretched to the left. So this is stretched to the left. If it's stretched to the left, the tail is to the left, the mean is to the left. Skewed left, stretched to the left, tails to the left, mean is to the left. Super important. I guarantee it's going to show up on the test. Skewed right. In this case, if my median were here, now this is being stretched to the right. It's obviously being pulled or stretched to the right. If that's where my median is, I know that my mean, I don't know where it's going to be, but I know it's to the right. So stretched to the right, mean is to the right. So once again, skewed left, mean is to the left. Skewed right, mean is to the right. Bimodal means that I have two distinct peaks, two distinct humps. They do not have to be the same size. This one happened to be symmetric, but it's also bimodal. This is not symmetric, but I have two distinct peaks, so it's also bimodal. All right? In both cases, if we have bimodal data, write this down, if you have bimodal data, then you need to discuss the center of both peaks. You need to, or give the location of the peaks. I need to give that location and that location. Here I'd give this location and this location. All right. All right, so page 50, spread. Spread, measure of spread is the data close together or how far away from the center is it, or how far spread out it is. Well, you learned measure of spread, I believe in elementary school, definitely in middle school, the range. And that's just the largest minus the smallest value. So the data in range is a single value. So don't say it ranges. The data, the range is a single value. And it'll always be positive, all right? Because it's always the largest value minus the smallest value. The interquartile range is another type of range, all right? But it's a little bit different. The interquartile range is basically the middle 50% of the data. So it's Q3, the 75th percentile value minus the 25th percentile value. And the reason we like the IQR is it's not impacted by outliers because it ignores the upper 25% and the lower 25%. The range, on the other hand, is always impacted by outliers every single time because it includes the outliers, whereas the interquartile range does not. Right, so we like using IQR as a measure of spread. Variance, there's a nice fancy formula there that's awfully complicated to talk about right now. We'll discuss it in about 2 weeks. Easy to use, it's built into the calculator. You already calculated it once. And basically it just tells you how far an individual value is from the average. So there's an individual value, that's the average of the population. I subtracted it and squared it, and I summed up all of those and took an average. That's all I did. I know that may not have made a whole lot of sense. Don't worry about it, other than the fact that you need to know that the variance takes an average of the distance from the median, from the mean, right? You need to know that first sentence. Then you need to understand that, and it's an individual value minus the mean. Individual value minus the mean. Standard deviation, on the other hand, is exactly the same thing, except we just took the square root of it. We just took the square root, and most of the time we talk about things in standard deviations. We rarely talk about variance, but we talk about variation, but we rarely talk about the variance calculation. Anyway, standard deviation is just the square root of the variance. So once again, individual values minus the average, all right? And then the very last measure of spread is known as a z-score. And it's just a ratio, and it's a ratio of the average, how far a value is from the average, how far the value is by the average, divided by the spread. So it's just a ratio. It's very, very powerful. You haven't learned what it is or how to use it yet. You will, but I kind of want you to know that these are your measures of spread. So we have measures of spread are your range, your interquartile range, your variance, your standard deviation, and then lastly, your z-scores. Now, in our case, when we CUSS and BS, we're going to need to talk about center, unusual, shape, and spread. Center, unusual features, shape, and spread every single time, and we need to be specific. In the next video, we are going to work some example problems where we have an opportunity to show that, and it clears a whole lot up for you. Thank you for participating.